Ever wondered how your phone tracks your movements in a fitness app, or how a robot knows where to grab an object? It all starts with keypoint detection, those tiny, precise markers that help AI see the structure of things. But here's the catch. Traditional AI models are great at big-picture tasks, like spotting a person in a crowd, but they struggle with fine details. Think of it like a detective who can spot a suspect in a photo, but can't tell you where their right eye is. Enter KptLLM++, a groundbreaking model that's redefining what AI can do. Imagine a system that doesn't just guess where a keypoint is, but understands it. Instead of relying on rigid rules, KptLLM++ uses a blend of text, images, and smart reasoning to figure out exactly what it's looking at. How? Let's dive into the mechanics. First, it tackles keypoint semantic understanding, figuring out what a keypoint is. If you ask, where's the right eye? It doesn't just say eye. It uses context to pinpoint right eye based on the image. Second, it leverages visual prompts, like showing it a sample face to help it find keypoints in a new photo. Third, textual prompts let it follow descriptions, like the right eye is on the front side of the face, even if the object is unfamiliar. The magic. A strategy called identify then detect. It's like how humans think. First, we understand what we're looking at, then we locate the details. KptLLM++ blends common sense from language models with visual and textual clues to reason through tricky scenarios. But here's the real innovation. It was trained on over 500,000 diverse images, different objects, styles, even occluded scenes. This massive dataset lets it generalize better than ever, achieving top results on keypoint detection benchmarks. Why does this matter? It's not just about accuracy. KptLLM++ makes AI more flexible and intuitive. Instead of one-size-fits-all solutions, it adapts to user instructions, whether you're describing a pose in text or using a visual example. This could revolutionize fields from AR/VR to medical imaging, where precise object understanding is critical. So what's a keypoint? Think of it like the GPS coordinates of a body or object. For humans, it's elbows, knees, fingertips. For a car, it might be hinges or wheels. But here's the problem. Traditional AI models are like picky eaters. They'll excel at detecting keypoints on familiar objects, say, a human's hand, but crash when faced with something new, like a giraffe's neck or a robotic arm. That's where KptLLM++ steps in. This model isn't just smart, it's curious. It combines the power of large language models, the same tech behind chatbots, with visual understanding. Imagine teaching a robot to read a description of a cat's tail and then spot it in a photo. That's the magic here. The secret sauce? A massive new dataset called MP100. Think of it as a training ground where the model learns from categories that don't overlap, like dogs and cows. But here's the twist. Even non-overlapping categories can have similar features. A cat's tail and a dog's tail. They're basically twins. To test if the model can adapt, researchers created supercategories, broad groups like human faces, vehicles, or furniture, and used them as test cases. This forces the model to think beyond memorization and actually understand patterns. And the results? KptLLM++ crushed the competition. On a test called AP10K, it boosted accuracy by 21.8 points compared to older models like CLAMP and Simple Baseline. That's like teaching a model to spot a horse's hoof and a cow's hoof with equal precision. But here's the kicker, it's not just good at what it's seen. By training on 8 diverse datasets, from Coco to animal pose, KptLLM++ learned to tackle unseen categories. On the animal pose dataset, it set a new record, proving it can adapt to entirely new species or objects. So what's the takeaway? KptLLM++ isn't just a tech upgrade. It's a leap toward AI that understands the world more like humans do.